Yesterday we talked about this weird funky ratio. Sankofa, going to shut the computer? Thank you, sir. Appreciate it. Well, yesterday we took notes here. Watch. Remember those? Yeah, here it is. 8 triangles. You recall this angle never changed. This angle always stood 36.87 degrees. And you recall that out of these 8 right triangles, every single ratio right here became 0.75, around there. And you recall that the biggest right triangle, we took the ratio of side BC over side AC. Look at BC over AC. It's on your notes. In other words, the side that's opposite the angle over the side that's touching the angle. In other words, the side that's adjacent. Opposite over adjacent, there's the first ratio. Look at the second triangle. Opposite over adjacent, there it is. Opposite over adjacent, there it is. And so opposite, adjacent, it kept going. And they all became the same ratio. Ladies and gentlemen, we were doing the tangent ratio, you just were unaware of it. Tan, T-A-N, is short for tangent in mathematics. So as we're filling this in, we're actually taking the tangent ratio of that angle. The side that's opposite the acute angle over the side that's adjacent. Now watch this. Watch. Coming back to example 1. I got 2 acute angles. Esquivel, can you name the 2 acute angles, please?
S
Thank you.
and R.
Thank you. That's the right angle. T's right angle. We want S and R. We want the acute angles only. In other words, when we do trigonometry, it's always with acute angles, never with the right triangle, or the right angle, rather. All right, let's find the tangent of R and then the tangent of S. Just like we found the tangent of this weird angle A yesterday. We found the tangent 8 times. Let's find the tangent now. Watch this. 2 times, 1 for each angle. So here we go. Underneath that, go to write tangent is. What's the numerator? Well, it's always the opposite. I'm going to write OPP for opposite. It's always the side that's opposite over the side that's adjacent. I'm going to abbreviate ADJ for adjacent. Tangent is always opposite over adjacent. You remember this, Medina?
Yeah.
You're going to rock and roll with this. Rodriguez? I got the floor right now, so that should be put away. It's like the 4th week I'm saying the same stuff from day 1. Should be. So the 2 acute angles, like Esquivel said, is R and S. I'll take the tangent of R first. Watch this now. Write this with me. Actually, before I even write it. Tangent, when you look at a calculator, I showed you my calculator during the warm-up. Look at this scientific calculator. You ever notice those weird buttons on scientific calculators? For instance, right here. Look at there's tan. Tan is for tangent. All these top 3 buttons we're going to get into. This is all trigonometry. Tangent, we're going to get into cosine, we're going to get into sine. Look at inverse tangent, tangent to -1 power. We're going to get into all that jive sooner or later. But we're going baby steps right now, just so you know. We're headed here, though. So let's go back. Let's take the tangent of angle R. The ratio, here we go, write it with me. TAN, short for tangent, of angle R is. Numerator is a side opposite to R. Miss Bass, what side is opposite to R on this triangle?
The number?
Give me the number.
45.
Rocking and rolling. You guys see that? That side's not touching angle R. It's opposite. And on the numerator, it's the adjacent. But when I look at adjacents, remember adjacent means touching. There's 2 sides touching R. This side and this side. The one I choose is the one that's the leg. When we do trigonometry, pick the one that's the leg, not the hypotenuse, for adjacent. So what side would that be, Vivetta? Well, the side. What side would be touching angle R? That's the leg.
Oh, RT.
Thank you, which is 24. Nice. 24 here. Let's turn that puppy into decimal. In other words, warm up. We did this for warm up already. Let's do it to the fourth decimal, please. 45 divided by 24 to the fourth decimal. Let me get my calculator out. 45 divided by 24. Was that it, or 24 divided by 45? 45 by 24?
Yeah.
My bad. All right, here we go. To the fourth decimal, we don't have to worry about it because it only goes to the third decimal. So I'm gonna name all the decimals, all the way to the third one. So 1.875. It's not, I don't even have to approximate because look, it's equal. It stops. So the ratio is 1.875. Not approximate though. It's actually equals in this case. We don't have to round off. Done. But Medina, what's the other acute angle? What angle? Thank you. Let's take the tangent of S now. Here's S. Okay, the ratio is always, the Santiago, you're with me? Opposite over adjacent. The Santiago, can you tell me what side is opposite S? I need help, let me know. What I know, come to the rescue. What side's opposite angle S?
24.
Gracias. It's not touching angle S. Now I want the adjacent to S, but there's two sides. I pick the one that's not the hypotenuse. Castillo, rock and roll. Which one's not the hypotenuse that's touching S?
45.
Gracias. 24 divided by 45. Let me hit this crap in my calculator, and we're done. 24 divided by 45 is 24 divided by 45 to the nearest fourth decimal. 10,000th place, in other words. Right there. To the right of it's not 5, so it stays at 3. There it is. So it's approximately, not equal now, we're approximating. Approximately 5.333. Or 0.533, what am I saying? 0.5333, done. Not a big deal. Today's lesson. We're going in baby steps. Now, you should be asking, okay, Mungia, maybe you're embarrassed to actually ask me, but maybe at least in your mind you're saying, Mungia, why are you so excited about these decimals? So what? Okay, so what use is that to us? What's the big deal about 0.5333? What, it doesn't do anything for us right now. We're getting these ratios, they mean nothing, absolutely nothing to me. Well, I'll put that in the back burner, because tomorrow I'm going to show you, actually not tomorrow, you'll be home playing video games. Friday I'm going to show you how useful those are. It's going to rock your world. But in the meantime, let's just do one more example of finding the ratios. Here we go. So example 2. Questions on example 1? Good. I don't feel like answering questions. Example 2. Write that down. Give you about a minute to write this puppy down. Same directions. Same directions. So you might want to just draw the picture because it's the same directions. We're going to find the ratios of the acute angles. Question so far? So opposite of S was 10. Adjacent was 24. There's your ratio. Let's do opposite of R now. R I'll put in green. Here we go. There's R. Who haven't I picked on? Let's go Medina. What side is opposite to R? Nice. Mr. Ramirez. What side is adjacent to R? Yes, my bad. 10. What's going on between both acute angles and tangents? What's going on here? One more time. What's a fancy schmancy mathematical word for switching a numerator denominator? Huh? Reciprocal. So just something to file in your mind. The tangents of both acute angles are always going to be reciprocals of each other. You flip those puppies. 24 divided by 10, I want to say, is exactly 2.4, right? Done. Again, right now you guys are little babies and infants in the playground, not understanding that even the blocks that you're playing with are actually building your logical skills and are actually profitable. You guys have no clue what these decimals mean. They're useless to you. They're meaningless to you because you guys are like infants. But Mungia is going to take you somewhere, and you're going to see the power of these ratios probably Friday or Monday. Okay? I'm glad you guys got the joke. That's cool. I'm going to put you guys in groups of 2. What are these guys doing here? Can someone tell me what these guys